Hello, Rajesh. Hello.
Sir, good afternoon, sir. Sir, చెప్పండి sir.
అందరూ వచ్చారా?
Yes, sir. Students are there, sir. Sir is going to join within 5 minutes.
Sir.
Sir is going to join within 5 minutes, sir.
Okay. Right. Good afternoon to one and all. So please maintain silence and don't switch on your microphone as well as your cam. Okay, all the students. It is a standing instruction for everyone. Don't switch on your video and audio. Okay. Right. So this Google Meet is limited to 100 members. We are going to share you within 5 minutes that YouTube link. So you can ask your friends to join YouTube. Okay. If anyone is left over, so we are going to provide you Google link. Sorry, YouTube link. So you can share your this YouTube link to your friends.
Sir, HOD, sir, YouTube link is already posted, sir, in the chat.
Okay.
Students, you please, the remaining students can utilize this opportunity. స్పీకర్ టాప్ చేయండి బా, నాకు ఇక్కడ వినపడదు.
Hello.
Sir, Ramesh sir. Good afternoon, sir.
Sir, welcome, sir. This is Chandrasekhar Reddy, sir. Welcome, Venkatramaya, sir. Hello. Meet line.
Sir, maybe he is in mute, sir. Yes, sir. Yes, sir.
Thank you, sir. Chandrasekhar Reddy, sir. Thank you for inviting
Sir,
me.
welcome, sir. Welcome, sir. Welcome, sir. Hearty welcome to SV. Actually, SVC, sir.
Little bit late due to net problem, yeah.
Yes, you can go ahead.
Sir, shall we start, sir?
Yes,
Yeah.
go ahead.
I will start now.
Okay, sir. Sir, good afternoon to the August gathering.
Yeah.
Sir, Ramesh sir, I will start officially, sir. Then you can able to continue, sir.
Okay, Rajesh, start.
Formally, I will start, sir.
Right, Rajesh, proceed.
Okay. So, good afternoon to the August gathering and welcome you all to this webinar on optimization techniques in manufacturing, organized by Department of Mechanical Engineering, SV College of Engineering, Tirupati. First of all, I would like to welcome our chief guest, Professor Dr. P. Venkatramaya, sir, who is now HOD of Department of Mechanical Engineering, SV University, Tirupati, for this inaugural function. I welcome our head of the department, sir, Dr. M. Chandrasekhar Reddy, sir, and also my dear colleagues and as well as my student participants. I welcome all. The main objective of this webinar is to provide an opportunity for the students and faculty to interact with leading expert in optimization domain. So the purpose of optimization is to achieve the best design relative to a set of prioritized criteria or constraints. These include maximizing factors such as productivity, strength, reliability, efficiency, and utilization. This decision-making process is known as optimization. Now I request our HOD sir for the welcome speech, sir. HOD sir, please, sir.
Respected today's speaker, Dr. P. Venkatramaya, sir, Professor and Head of the Department, SV University, faculty members of Mechanical Engineering Department, and my dear student friends, good afternoon to one and all. It is my privilege to invite Dr. P. Venkatramaya, sir, to virtually to SVCE. I'm all thankful to, also thankful to sir for readily accepting our invitation in spite of his busy schedule to deliver a webinar on optimization techniques in manufacturing. This webinar will be useful for faculty who are interested to pursue in manufacturing and also for students to carry out their project work in manufacturing. Management, faculty members. Thank you, sir. Thank you once again.
Thank you, Chandrasekhar Reddy, sir. Thank you very much.
Sir, thank you, sir. Sir, just I will give a brief introduction about you, then you can proceed, sir. 2 minutes, sir.
Okay, Rajesh. Please.
Sir. Thank you, sir. Sir, today you can see our P. Venkatramaya, sir. He is our He is a professor and head in Department of MESU University Tirupati. Sir has published more than 70 international journals and conferences, 41. He has acted for resource person for various guest lectures, seminars, conferences, and chairperson on machine tool dynamics, vibration engineering, and design optimization. Sir has organized various workshops in his field through various government funding agencies for the students and young researchers. Sir has awarded 7 PhDs. Out of them, I am also one. I feel proud of sir. Then under his guidance, 8 are pursuing, and sir has guided them PG projects 56, which are completed, and 5 are pursuing. And coming to his research profile, he has citations of 431, out of which H index he has 10 and I-10 index of 13. So he is life member in various societies like ISTE, TSI, IE, and IAENG. And he is a member in various committees like BOS, institution policies, and other autonomous colleges. Earlierly, Sir has served in various positions like as additional chief superintendent of examinations, nodal officer in workshop superintendent in SV University. Sir, now over to you, sir. Thank you for coming to our college, sir, in virtually. Now over to you, sir.
Okay, Rajesh, thank you for introducing me in a nice way.
Thank you, sir.
Then I want to go in my presentation.
Yes, sir, I will stop my presentation, sir. You can proceed, sir.
Okay, Rajesh, right.
Sir, now
Thank
over
you.
to you, sir. Yes, sir.
Thank you, Rajesh, for introducing me in a nice way. And on your request, I accepted. I think it is more useful to your student to carry out the project works, especially in manufacturing area. Are you hearing me?
Yes, sir. Yes, sir. I can hear you, sir. Yes, sir. Please, sir.
Anything is there, you inform me, I will rectify. Okay. Any
Okay, sir.
mistake,
Sure, sir.
yeah,
Sure,
any
sir.
problem. Right. So regarding to my presentation today, optimization techniques in manufacturing. The brief outline of my presentation in this session. What is optimization? Optimization in manufacturing, optimization methods. I'm going to focus mainly on these concepts. And some case studies I want to show on different aspects, how we have applied the optimization techniques in our project works, especially. So coming to this optimization, in what is the need of optimization in manufacturing?
Sir, excuse me, sir. Sir, we cannot see your slide, sir.
Okay. Share, already I have shared. Huh?
No, sir, it is not showing, sir.
1 minute, Rajesh.
Okay, sir.
Now, okay?
Not yet, sir.
Not yet. Already I click the shared option also.
Sir, you have to go to present now. Like that you did now, sir.
Present. Okay. 1 minute, Rajesh.
Okay, sir.
Now, okay? Not yet.
Not yet, sir. We will wait, sir. No, sir, no.
You call Mr. Prabhukiran immediately. He went away.
Okay, sir. I will call him, sir. Yes.
Okay, then he left his phone with me only. 1 minute.
Sir, you do one thing, sir. No problem, sir. Go to present now. Then select the window option.
You tell me, Rajesh, you guide me in this.
Yes, sir. No problem, sir. Go to present now, sir.
Present now.
Then you click window option. Window.
Okay.
The window option will be there, sir. Can you see, sir? Window option.
Window option. Rajesh, now actually
Sir.
it was opened on the screen.
So you please close the screen, sir. Then you have to repeat the same process.
Yeah. You tell me now.
Now go to present now. Select the window option.
Present. Okay, good.
Sir, before that you have to open your PPT.
Present now. Yeah. Next
Window.
Good.
Then, sir, before that you have to open your PPT. Can you see your PPT on that block, sir?
Yes.
You select that PPT, sir. Then you press share.
Share.
We will wait, sir, because you said that your net connection is slow. It should open, sir.
Yeah, already it is sharing.
Yes, sir. Yes. Sir, now I can see your entire screen, but I should see your PPT. You minimize the screen, sir. Minimize,
na? Okay.
Yes, sir. You please minimize this one.
Then
on the top left, sir. Top right, sorry, sir. Top right. You minimize that screen.
Already minimized.
No, sir. Here I should, sir, మీరు ఈ ఆప్షన్ తీసుకోకుండా సెకండ్ ఆప్షన్ తీసుకోండి సార్. మళ్ళీ క్లోజ్ చేసేసి స్టాప్ ప్రెజెంటేషన్ చేసి you please select second option. Yes, sir.
చెప్పండి సార్. Prabhu Kiran, you see that? Rajesh.
Sir. Still we cannot see your screen, sir.
ఏమ్మా ఏం వచ్చింది? What, Rajesh?
No, sir. Still we cannot see the screen, sir.
PPT open.
Sir, you please give a call to Prabhu Kiran, sir. Sir, I will inform you.
He is here with me only.
Okay, sir. Sir, you please go to present now.
Yes,
then the window option. Can you see that, sir?
Come present now, sir.
Window present now. Then a window.
Yes, sir.
Before that, you please open the PPT. Then you select the PPT, sir. PPT. That is sufficient, sir. Then you press share.
Sir, it is visible, sir. PPT. I open PPT.
Sir, మీరు షేర్ చేశారు దాన్ని?
షేర్ చేసింది
సార్.
లేదు సార్, ప్రెజెంట్ నౌకి వెళ్ళి అక్కడ మీకు ఏమే ఆప్షన్ కనిపిస్తుంది సార్?
ప్రెజెంట్ నౌలో విండో ఉంది.
విండోలో తర్వాత మీరు ఆప్షన్ అక్కడ తీసుకోవాలి. PPT తీసుకోవాలి, సెకండ్ ఆప్షన్. ఫస్ట్ తీసుకోవాలి మీరు ఇంతకు ముందు మీట్ అనేది, అది కాదు పక్కన తీసుకోవాలి PPT. అప్పుడు PPT వెనకాల మీరు ఓపెన్ చేసి ఉండాలి అంతే. PPT minimize చేయకూడదు సార్, maximize ఉండాలి PPT.
సార్ షేర్ అయితే ఉంది ఆల్రెడీ షేర్.
Yes sir, now it is coming. Yes sir. అదే సార్, మళ్ళీ మీట్ వచ్చింది, PPT రాలేదు. Now we can see your meet sir, not PPT. సార్ ఇప్పుడు మీరు క్లిక్ చేశారు కదా సార్, అంతకన్నా ముందు PPT ఓపెన్ చేసి వెనకాల పెట్టండి, అంతే. ఓపెన్ చేసి పెట్టుకోండి, మినిమైజ్ చేయదండి. సార్ ప్రభుకిరణ్ సార్, PPT ఓపెన్ చేసి మినిమైజ్ చేయదండి, బ్యాక్ లో పెట్టుకోండి. ఇప్పుడు చూడండి. ఎస్ సార్, నౌ వీ కెన్ సీ యూ సార్. సార్ ప్రభుకిరణ్ సార్, స్లైడ్ షో పెట్టండి సార్ కి. స్లైడ్ షో ఫస్ట్ స్లైడ్ కి వెళ్ళిపోండి, స్లైడ్ షో పెట్టండి సార్.
ఓకే సార్.
ఓకే సార్, ఫస్ట్ స్లైడ్ సార్, ప్లీజ్ సార్, ఫస్ట్ స్లైడ్. Sir, no, okay, sir. Please, sir, you can proceed, sir.
Rajesh, thank you for all these inviting
No
me.
problem, sir. Please.
Sorry for disturbances came. Now presentation outline, so I have given what is optimization and how the optimization concept applied in manufacturing. What are the different types of optimization methods? And various case studies, I want to show you different case studies, what we have done in our project works and thesis, and really useful in practically in industries. What is the need of manufacturing? What is the need of optimization in manufacturing? Means every walk of life in our industry, from the raw material stage to finished product stage, then to customer level, how the optimization techniques are being utilized and used really. Really, we gone through different optimization techniques, even at raw material stage also, even at the process level also, even at end stage, even at customer service stage also, entire product life cycle, how the optimization concepts we are using. Basically, in rapid scenario, changing scenario, application of optimization techniques, especially for increasing trend in the quality of the product, certainly there is a demand for the advancements of the advancement of the optimization concepts, and also still research is going on, a lot of scope in this area. What is optimization? Really, everybody know that optimization means minimization. Everybody perception like that. Optimization means minimization, not minimization. If you formulate a function or if you formulate a certain work, so how to optimize that work subjected to some constraints. Constraints are also very important. How to utilize the resources, or effective utilization of the resources subjected to the constraint. For example, everybody feeling that minimization of cost is always good, but without compromising the quality, we have to minimize the cost. So there certain bounds are, especially we have to apply either on the minimization or maximization problem. You see that the first line optimization comes from the optimal. Optimal means it is the best. How to obtain the best and how to make the best. Either maybe it may be a maximizing or minimization. These are the two kinds of the problems available in the real industry. Definition, come to the definition. It is an act, process, methodology of making something. It may be respect to the design, system, or respect to the decision. So coming to the need of optimization for the quality products, need of optimization. So especially maybe everybody thinking that the optimization is only either maximization or minimization. Merely, certainly not. Even at the process level, even at design level also, we can apply the optimization concepts. Customer satisfaction is very, very important. Customer satisfaction. So, how to control the different parameters with respect to the customer satisfaction? Because one side is customer satisfaction and other side is different parameters. How to Rajesh. Rajesh, any problem?
Sir, no problem, sir. Please, sir, carry on, sir.
Okay.
It is clear, sir. No problem.
Now clear now. Okay. So aim of any engineer is to carry out optimization. Okay, keep on optimizing many things even without optimization techniques also, because by experience, based on experience also, you can optimize the various process and various even products also. In the optimization, major steps are there. Definitely, we need some mathematical model for optimize the either process or product parameters. And then once we have ready-made solution, ready-made equations and objective functions, then we can optimize them by solving with the help of different optimization algorithms. Basically, so any objective function, it is subjected to some restrictions. So, for example, availability of the material, the resources are scarce in nature. So, power is scarce, then material is scarce in nature, then all the resources, material, methodology, everything. These are all restrictions posed on the objective function. And with respect to that, we have to minimize the different factors like, for example, if you take a machining process, speed, feed, depth of cut, lubrication, these are all different parameters really which have more influence on the responses, even production rate. So definitely, to carry out any project work or any research project, first we have to decide the objectives. Generally, to decide or define any objective, some scientific basis is required. Scientific basis, a background. So without that, we can't define it. For example, if you take this is a case study, the particular machining problem. First one is how to determine the optimum process parameter levels for individual responses. Then another one is how to determine the optimum process level for multi-responses, maybe sometime individual responses, multi-responses, and then contribution of process parameters on these responses, contribution of process parameters on these responses. So like that, objectives will be slated like that and define these objectives. Because this is this kind of establishment of the objective is necessary to carry out any project work. For example, you see this, how really the optimization process will be done. Need for optimization. First, without any need, we can't apply the optimization process or optimization technique anywhere. First, we have to identify what is the need. So based on need only, we can apply the optimization methodology. Then based on that, choose design variables. Design variable means what are the parameters to be controlled. That parameters are identified. So based on the brainstorming session or based on any experience, we can decide the design variables. Then formulate the equations or constraint. Formulate the equations or constraint. So constraints are either resource constraint, or maybe already everybody made aware of that, and linear programming, let you take linear programming. So in that, what is the objective function? What are the different constraints? The constraints with respect to the resources. Okay, design variables are X, Y, like that we can decide. So independent variables, design variables are independent variables. So these are also called parameters. They set up the bounds. Bounds means upper limit and lower limit can be fixed. Then you choose an optimization algorithm for solving the problem. This is a general methodology. Everywhere I made aware of that. And these are the different optimization methods. These are the different optimization methods available to apply either in manufacturing or metal cutting area, especially. And these can be extended in all kind of problems, extended to all kind of problems, not only for manufacturing, not only for metal cutting. So after establishing the objective, once we have decided on how to optimize the what are the requirement and what are the constraints, everything. Once you establish the objectives, then you apply these. Then you apply the optimization methods to optimize the process parameters. Single response optimization, multi-response optimization methodology. Okay, these two methodologies are available. Single response optimization means one response problem. So generally it is predominantly Taguchi SPN ratio analysis methodology is very, very important one, even though it is a early methodology. More useful still now, having old till now, to solve single response optimization problems. Multi-response optimization problem, gray relation analysis, fuzzy logic, Deng's approach. Okay, and many optimization techniques are available in that, and predominantly gray is one of the best multi-response optimization technique, and even fuzzy logic also. Then regression model based optimization method, the genetic algorithm, immune algorithm, SCA, sine cosine algorithm. SCA means sine cosine algorithm. Many lot of. So these are important examples given. Rajesh, camera.
Sir, no problem, sir. It is clear, sir. Please, sir, proceed, sir. Sir, Ramesh, sir?
Rajesh.
No problem, sir.
Okay. Then first I want to explain about Taguchi methodology. It is very, very important methodology. Many researchers still using this concept, Taguchi methodology, for parametric, for experimental designs, and then data analysis process. Most of the majority of the cases, right? Even though it was developed in 1980s, still having, it is valid, still good. These are the different steps in Taguchi methodology. But the majority of the people thinking that Taguchi method is only for designing the experiment. Not only for design of experiment is one of the part in Taguchi methodology. So these are the different steps. Select the quality characteristics to be optimized. Quality characteristic means some response. For example, if you take the metal cutting process, surface finish is one of the important factors there. So this is one of the quality characteristics. And production rate, for example, you take in manufacturing process, production rate is one quality characteristics. Production rate. How many, what is the quantity to be produced per hour, per week, per day, per week, per month, like that. The production rate will be is the quality characteristics. So like that, the quality characteristic means output response. Output. Okay, are measured parameter at the end. That is the quality characteristics. Then identify the noise factors and test conditions. Noise factors are uncontrollable parameter. For example, you see the matter here. So here, parameters or factors are two types. Noise factors means uncontrollable factors, and another category, control factors. First, we have to decide what are the controllable parameters. Parameter or factor, same meaning. Parameter or factor. Controllable parameter means which are under the control of operator or under control of the man who is working on the mission or who is working in the process. Uncontrollable parameters are not in the hands of operator or controller. So, for example, environment. Environment is uncontrollable parameter. Morning shift, evening shift. If you go to morning shift and evening shift, some type of climate in the morning and some type of climate in the evening, it may affect the manufacturing process. And of experiments. And another one is data analysis. Then I will show all these things with the help of some case studies. Easily you can understand. So this is the matter. Matrix. Conduct the experiments according to orthogonal array. I will show it. So orthogonal array. So actually, I will take one case study problem. Using that, you can easily understand the case study 1. So, for example, if you take the machining of any workpiece, for example, drilling process. So, if you analyze the drilling process, what are the parameters here? Type of work material. Just you go to the machine shop and observe what are the influential parameters really affect the drilling process or any machining process. For example, type of work material used, whether cast iron, what type of factors will be there, and mild steel, what type of factors. Because material to material, something will vary, and then responses.
Sir, excuse me, sir. 314. 314. Yes, sir. Sorry, sir.
Yes.
Sorry, sir. Please.
Yeah. Responses in drilling. So generally responses means after cutting or while cutting, what happened. So after cutting, definitely we may expect what is the roundness of the drill, surface finish of the drilled hole, then burrs. So these are the expectations. Finally, responses in drilling, what we observe on the screen. Power consumption, temperature, surface roughness, burr height, hole drill diameter, thrust force, torque. These are the different responses can be observed while drilling or after drilling also. Some parameter surface roughness we may observe after drilling only. Then let you take, this is just example. This is an example for your understanding purpose. These have been presented to you. And these are the influential parameters. So while drilling, what are the influential parameters? Influential parameters means the parameter really influences the drilling process, and definitely the responses is under the influence of these parameters only. So, for example, table will be prepared like this. Not only for this concept can be extended to any process, any methodology also. For example, parameters: spindle speed, feed rate, lubricant, drill coating, point angle. So these are the different parameters. Influential parameters have been considered here, and levels also fixed like this: level 1, level 2, level 3. What are these levels actually? Based on practice, these levels can be fixed. So 250 RPM. What is the reason to fix this 250 RPM means? Depending upon the material only, we can type of the material. For example, type of material is mild steel. So for that, these levels can be fixed. So after having some brainstorming sessions, after having some discussions with workers, share their experiences, and based on them only, these values will be fixed. This is one of the steps in Taguchi methodology. Taguchi methodology, this is an important step, fixing the parameters and their levels. Okay, so based on experience only we can get it, none other than that. Influential parameters and their levels. So once you decide this table is very, very important one. Even in the design of solar collectors or design of engines case also, same type of process may be followed in any case. A number of experiments to be conducted. So actually really, full factorial experimentation and fractional factorial experimentation. Full factorial experimentation means, for example, L power F, L power F. Here parameters are 1, 2, 3, 4 parameters. Point angle 1, 2, 3, 4, 5 parameters. Totally 5 parameters. And their levels are 3. So L power F, number of experiments to be conducted, L power F. Total number of experiments, maybe for example, 3 power 5. What is 3 power 5? Almost 273. 1 minute. So multiples, full factorial, for example, 2 power 5. So instead of conducting 2 power 5, so we may choose the option L power k minus p. L power, yes, 243 experiments. Instead of conducting all possibilities, 243 experiments, it is a time-consuming process and totally resource waste. So for that reason, we have to sort out the fractional factorial design. So this fractional factorial design, one of the important concepts of Taguchi methodology. So maybe predominantly Minitab software is available. Using that directly, we can sort out or we can design the experiments directly. Another methodology is response surface methodology, RSM. This is also one of the leading experimental design methodology. Number of experiments to be conducted, like for example, DOE, design of experiments, L27 Taguchi method, Taguchi orthogonal array. That orthogonal array, Rajesh,
Sir, చెప్పండి సార్. Please, sir.
is it okay?
Okay, sir, no problem, sir. Better full screen, sir. Yes, sir. Now, okay, no problem.
Camera కావాలని అవసరం లేదు కదా?
No need, sir. No need, sir. No need.
Okay, right. Right, this is DOE, or the design of experiments. L27 means it is a, so instead of conducting 243 experiments, only 27 number of experiments, 27 experiments came out from Minitab software, or certain methodologies available. Already these are all established tables given by Taguchi in any quality control textbooks. It is separately available at the end, or directly you can get it from Minitab software as output. This is S/N ratio analysis. This is also one of the inbuilt concept in the Taguchi methodology. S/N ratio means signal to noise ratio. S means signal, N is noise, signal to noise ratio. So these values. So certain mathematical procedure is also available to carry out all these kind of analysis. S/N ratios, finding the S/N ratios is next step for all responses. For all responses is power consumption, temperature, surface roughness, burr height, hole diameter, thrust force, torque. So these are all responses. For them, S/N ratios have been evaluated. And then this is also one of the quality characteristics which is to be needed. Smaller the better, larger the better, nominal the better. What is meaning of this is what is smaller the better? What is that? For example, you take power consumption. Power consumption in the first column, power consumption. Smaller is the better because consumption is always you have to minimize. That parameter must be small. That is the meaning. Temperature. Temperature also. Minimum temperature, if developed temperature must be minimum. So that's why minimum is the better in that case also. And coming to the surface roughness. Surface roughness also the characteristic which is to be minimized, which is to be minimum. Or height is also to be minimized. Hole diametric error, this should be minimized. This should be minimum. Thrust force should be minimum. Tap force minimum. What are all the responses here should be minimum. Should be minimum for better measuring process or for better drilling. Larger the better. Larger the better case where it should be happen means, for example, material removal rate in some cases in our machining, material removal rate must be larger. Nominal is the better. In that case, neither maximum or minimum to be required. In that case, nominal is the better. In certain circumstances, we may use this concept also. So this type of graphs directly we can get it from Minitab software for optimizes for getting the optimum parameters with respect to the responses. So surface roughness, for example, this thing, surface roughness, with respect to surface roughness, how the optimum combination of input parameters or influential parameters is obtained. The best thing is already you came across that spindle speed, feed rate, and lubricant, type of drill angle, and everything. These are the influential parameters. For that, for minimum surface roughness, so this is the combination obtained. Okay, this is a combination obtained means, for example, you see this horizontal axis and horizontal axis levels, and vertical axis S/N ratio. So for example, first one. So this is in S/N ratio. The maximum value of S/N ratio is to be considered for the best value, right? In this case, 250 is the maximum one. So here 0.3, feed rate 0.3 is maximum, and here number one C3 means. So these are the here I gave it already. This one 1, 2, 3, right? So same thing, this is an example, and same thing can be extended for multi-response optimization. Same thing can be extended by using Gray relation analysis. Gray relation analysis is multi-response optimization methodology. So in there, so many steps are there. So I will show that with help of a case study where I have applied this. Just a minute. Papers. Minimize cheyala. Papers become open that. So for example,
Sir, we cannot see, sir.
this is
No, sir. Again, you have to go with stop presenting. Then you have to show the papers if you want to show the papers.
1 minute.
Yes, sir. Rajesh? Yes, sir. Yes, sir.
Right. So you see this. So this work I have done, this work almost 10 years back, where we have applied the gray relational concept and Taguchi methodology in cover plate manufacturing unit, cover plate manufacturing casting unit especially. This is one of the very important methodology where I have applied by integrating both statistical process control and Taguchi methodology. This is very, very leading concept at the time, leading concept. Process and parameter optimization in a foundry unit for the improvement of production yield. Really, in our title, how the optimization concept will be really in manufacturing area. This is one of the best case study, really very much useful to you to carry out your projects also. Here, this work was actually done, what I have reported here, both process level optimization and parametric level optimization. So actually in the olden days, the people are only concentrated only on end product inspection. For example, once you produce a casting, at the end, just simply you inspect it, all these dimensions and all. So once the dimensions are okay, then you accept it. Dimensions are okay, then you accept it. Otherwise, simply they reject it. That is one of the ruled methodology. This methodology have been used earlier. So that concept totally replaced with the scientific methodology. Next one is statistical process control. Statistical process control, SPC. This is one of the leading concept. Even now, it is also holds good. Industries are using now statistical process control, SPC concept. Instead of focusing at the end, you concentrate in the process itself called statistical process control. Okay, so this is just you see, this is the I have developed this flow chart and this methodology. You see this phase 1 and phase 2 process optimization. Then first one is parametric optimization, then process optimization, then adjustments required at the parameter level. If no adjustment required, then you proceed for process. Then adjustments required, yes, then you change the parameter levels. So they really, with the help of a case study, you can easily understand this, how the concept really utilized. So for example, this is the casting unit where I have applied. So in phase 1, this work really done in 2 phases. Phase 1 is process optimization and phase 2 is parameter optimization. Process optimization, so these are the steps. Because while in the process, simply observing these, for example, first step, aware the responsible person regarding the quality production and train in respective areas. Create the awareness. So earlier in the even in 90s, the people working in industries may not aware at the time about techniques. After implementing all these means ISO concepts and all, really it was more useful industries for educating the people who are working there. These kind of concepts at the time predominantly used for the development of overall development of the organization, and thereby we can increase the production rate, quality, and everything. So that type of total quality concepts, many concepts are evolved at the time. Generally, these are the steps really involved in that. Aware the responsible person. Responsible person means, for example, you go to the foundry section. Really, I went there at the time 10 years back in foundry unit. Aware the people and how to work, and then what will be obtained at the end. What are the problems we are facing in the process, process. Rajesh,
Sir?
okay, na?
Okay, sir. No problem, sir. Please, sir. Carry on.
Identifying the priorities. Priorities means which will be done in first, then after what. So that type of concepts really more useful and educated them in that area. So analyzing the process. So that is also very important one. Installing the control charts, bringing the process under control. These are the steps really parts of the SPC. Then regarding to that, so after that, then data collection. So before implementing the phase one, for example, phase one means before implementing all these 5 steps, what was there in the industry? Just simply I scroll it. So this is the Pareto chart, one of the important chart tool, SPC tool. So according to this, so these are the defects. For example, sand drop, cold shut to shrinkage, blowhole, crack. So these are different casting defects. So due to that, the items were rejected. So this is 2533 tons of iron, total in terms of total iron, is wasted due to wastage due to defects. So in terms of kgs, you see this, right? 25,000 for 2 lakhs, 25, 2 lakhs, sorry, 25,000, 25.33 tons, okay, by 1,000 I can put it. 17.17 tons, tonnage, okay. In terms of tons, this is the material wasted due to these defects. Simply through visual inspection, they can say simply they are rejecting all this. Again, reprocessing and all, it is a cost consuming process and also time consuming and cost consuming. This is the real picture of that industry so before implementation of the phase one. So after collecting this data, one chart was drawn, that is P chart. P chart. This is the process average. Actually, process average is 0.2, means 20% average. Upper limit and lower limit have been fixed. This is UCL, means upper control limit, and this is lower control limit. P chart was drawn. So a process average is 20%, means 20% of items were rejected at the time before implementation. Then cause and analysis. So this cause and analysis concept was applied, and then data was analyzed. And then what are the reasons for these defects? Actually, what is the sand drop? So sand drop reasons. So this is like a fishbone diagram. It's a Japanese concept. So these are the causes, sand drop. These are all various defects, and these are all arrow marks are reasons for these defects. And finally, this is the output, like head of the fish. This is like a fish, so hence it is called fishbone diagram. Different reasons, all right? So for a sand drop, these are the reasons: poor sand, excessive turbulence, loose ramming, improper mixing. These are the reasons for sand drop. So like that, all the reasons have been explored. So once you rectify these reasons, these are definitely we can obtain the defect-free product, or at least we can reduce the defect rate, rejection rate we can. This is called cause and effect diagram. Cause and effect diagram. This is also called fishbone diagram. This is one of the important concepts we can apply for any kind of problem. Then install the X chart and R chart. Again, bringing the process, bringing the characteristics under control by correcting the deviation. So like this, we can prepare a chart like process parameters. So environment to equipment to procedure, measuring process, information system, raw material, methods, training. These are all influential parameter in the process. The process parameters, especially. Coming to the product, which is confined to the product, right? Product is different and process is different. Here, in the casting industry, The process is where what type of machines we are using, the people are using, what type of raw material we are utilizing for that. This is called entire industry process. Then product, what type of product finally, end product we are going to produce. The casting is the product finally. So what are the required characteristics for the product? Quantities to be produced, good strength, cost. These are the characteristics. These are also called responses. What I have given the earlier slide. The responses are output or quality characteristics. These are called quality characteristics. So once you see this, it is a cycle. This is the cycle. So first you cause and effect analysis, then you analyze the process parameters, then you see the product, measure the product characteristics, then the cycle will be repeated. The cycle will be repeated. It is a continuous process. So we cannot stop. We cannot start this process for a while. You do collect the data, get the feedback, and then you repeatedly do it cyclically until defect-free product or zero defect. This is the cycle. Next, after implementation of the phase 1, next one is this is SPC. So you see this system for process control, means statistical process control. Then second, phase 2 is the Taguchi. Then after implementation, again the data was collected and analyzed. The process average was reduced, process average. So you see the process average, then only 14% or 15% of the process average. The first cycle earlier, so it was the process average earlier. For example, so here the process average is 20%. Then before implementation. Then after implementation, the process average is decreased to or reduced to 15%. Process average dropped to 15% in one cycle. So like that, repeatedly, if you do the same thing, definitely the process average approaches to zero. So, but in the case of process optimization, SPC, it is not possible. This is only possible with the parametric optimization. At the design stage, if you control it, definitely we can reduce the parameter. We can reduce the defects or up to zero level also. It is possible with after completion of many cycles. So next is phase 2. So same thing, we implement this Taguchi methodology in phase 2, parametric optimization. Selection of objective, selection of factors and the level, Taguchi design, and conducting of experiments, then analysis of result. So this has been clubbed here. So we have, you see this parameters. So these are the parameters: pouring temperature, okay, grain compressive strength, GCS, carbon content, silicon content. These are with respect to a particular product. The data was collected like this, 1 and 2 levels. For example, this is 1395 green pouring temperature, 1395, level 2. So like these 2 levels have been considered. So after having discussions with the plant people, these 2 levels have been fixed. Then coming to this, then once these levels already we gone through the parametric optimization, metal cutting. So same thing, same concept even in manufacturing process like this, it have been used. Then L9, experimental design, L9. So L9, these are the parameters, level 1, level 2 of what, right? Temperature, these parameters like fixed, and you we conducted the experiments. Then finally, production yield was measured. Production yield means after rejection, what is really the accepted quantity is the production yield, 68%, 69%. Means remaining thing is rejection rate, right? This is accepted quality or accepted quantity has been recorded during all experiments. Here actually 8 experiments have been conducted because of 2 levels. 8 experiments have been conducted, and gray relational analysis theory methodology have been applied for finding because the methodology and all after that if you need definitely meanwhile I will explain about the procedure everywhere it was found, and in that so finally after the analysis we got the optimum results. So based on that optimum results, so you see this optimum levels. After analyzing the data by using gray relation analysis, so the pouring temperature is 1420 degrees. These are the optimum parameter levels have been determined after analyzing the data through gray relation analysis methodology. So same thing again implemented and conduct the experiments. Then we observe the process average is 10%. You see that. So initially it was 20%. Then after implementation of statistical process control, 15%. Then again it was dropped down to 10% in one cycle. In one cycle, it is dropped down to 10%. So 20 to 10% is drastical improvement in that. So these two process concepts are implemented. Process optimization and parameter optimization, both are integrated. This is integrated approach, integrated concept. Okay. So now come to the flow diagram, flow chart. The process of parameter optimization, then any adjustment will be taken or deviation, then parameter optimization. Like that, the cycle is, you repeat the cycle until zero defect or until 100% accepted rate. So like that, we can utilize these concepts in one case study. So another case study is, now it is clear, I think. So how to utilize this concept in manufacturing unit like casting unit. So another one is maybe we can use, I will go to slide. What Rajesh?
Sir, now we cannot see, sir.
So up to last slide, it is okay, na?
Yes, sir, it is okay, sir. No problem, sir.
If anything is there, then I will adjust it, rectify.
Sure, sir. No problem, sir.
Right. So coming again, coming to the presentation, I'm coming back. So there are different optimization methodologies we have gone through. Right? So multi-objective optimization using fuzzy logic. Even gray relation analysis also multi-objective. Multi-response optimization.
Sir, small request, sir. Slideshow mode, sir. Full screen.
Right.
Okay, sir.
Yes. Multi-objective optimization or multi-response optimization also. The fuzzy logic is one of the important technique can be used for optimizing the multi-response problems. Like gray, this is also one of the important concept, gray concept. So here many rules have been formulated. So directly here rules, and then on grade, fuzzy grade like that. Like SPN ratio analysis, what we have discussed earlier, SPN ratio analysis. S by N value and fuzzy grade both are similar. Once you've gone through a particular technique, so definitely that will be reflected in all type of techniques. It is same, holds good. Once you understand, the logic is very important here. So fuzzy grade, and these are the different inputs like speed, feed, depth of cut. So for example, you see this. So temperature, thrust force, these are different responses, and in reverse way. One fuzzy grade to again reverse prediction will be possible here. So same problem, what I have applied, the gray relational analysis and the particular data, and same data we can apply even fuzzy logic concept also for determining the best parameter values or optimum parameter combination can be obtained by using fuzzy logic with different. Then, and next one is, it is very important concept here is confirmation experiment or confirmation test. So, for example, again I go back, I am going back. You see this, again in the Taguchi methodology. So all methodologies are similar in nature, all are interdependent, and earlier one is Taguchi methodology. So based on that, many methodologies have been evolved. All methodologies somewhat relevant to the Taguchi methodology. So confirmation test at the optimal level. This is common for all type of problems, all type of methodology. This is a common step at the end. Confirmation test definitely, certainly we have to conduct. Once you got optimal parameter combination, then we cannot be, no need to believe this is the best value obtained and this is the best result. First you confirm it. Means again you conduct the experiments, and then after that only we can believe it based on the results. This is called confirmation experiment. This is called confirmation experiment. And confirmation experiment is must and should can be done at the end of any process, at the end of the, and pertaining to any methodology. Genetic algorithm is also one of the important step, and this is belong to regression model type of equations are required. For example, already I told you in the beginning, in the case of optimization, single response. Yes, slide. So single response optimization, now it is clear. The single response optimization, Taguchi SPN ratio analysis is single response optimization, means only one response characteristics. Then multi-response optimization means many responses, like in drilling process, what we have observed, per height, surface roughness, then power consumption. There is many responses belong to the multi-response optimization methodology. And regression model based, this genetic algorithm, regression model based algorithm means for applying genetic algorithm, definitely we need regression models. We need regression models. You develop the regression models from the collected data only. For example, you see this. Yes, this one. So for power consumption, this is the equation developed. Regression equations, everybody made aware of that, and how to develop the regression equation. Simple mathematical concept. So you take the data, then you develop the equation. You fit a curve in that particular data. Temperature of the tissue, surface roughness. So for them, you develop the regression models. So once you develop the regression models, then definitely we know the optimization concept. Objective function is required, and then constraints are required. These objective function must be subjected to the constraint. So objective function is this one, power consumption is one objective. Minimize the power consumption. This is the objective. Minimize the temperature of the testable. Or minimize the surface roughness. So these are all minimization objectives. You combine all these objectives and formulate as a single objective. And then these objectives must be subjected to these constraints. So constraints are spindle speed. For example, already levels are there. 250 is one level and 650 is one level. What is that? And you may not doubt. And feed rate. Again, I go back to the table. So here, so you see the spindle speed 250 and here 630. This is the minimum bound and this is the maximum bound. Like that you formulate feed rate, minimum, maximum. Okay, minimum, maximum. So same equations here. You formulate the equations before optimizing the problem. So these are the bounds like that. You can fix it and directly give the input. Give the input to the toolbars, solution will be obtained. Okay. So these two cases and Rajesh.
Sir.
I will show one more paper, Rajesh.
Sir, you said that you have meeting at 3 o'clock. Is it okay for you, sir? We are okay. We are ready, sir. No problem.
Okay, no problem. I will show one more case study.
Okay, sir.
Can you spare me for 5 minutes?
No, sir. No problem, sir. Please, sir. Please go ahead, sir. Sir, you should not minimize, sir. You have to stop presenting, then you have to choose.
Stop sharing. Next. Paper. Paper minimize చేసిన. అదే ఇంకో పేపర్ ఉంది, అది కూడా చెప్తా. ఆల్రెడీ ఆ పేపర్ అయిపోయింది, ఇంకో పేపర్ అసలు వన్ మోర్ పేపర్ ఏముంది, మినిమైజ్ చేసి మినిమైజ్లో ఉన్నాయి. రైట్. అది ఓపెన్ చేశారు, అదే రైట్. ఓకే. So I want to present one more case study. It was done in our laboratory. Optimization and prediction of process parameters in phase milling of this. So here, is it visible, Rajesh?
Sir, if you just zoom in that, then it will be clear, sir. More clear. Yes, sir. Yes, yes, sir. Yes, sir. Yes, sir. Enough, sir.
Sir, now you can understand. Finally, I will conclude it with this paper. Control parameters, influential parameters, factors, same meaning. Okay, take it granted, and the same meaning it have. Maybe in different perceptions, we are using in a different terminology. So controllable parameters here already speed, feed, depth of cut. DOC depth of cut. Actually, how these values, maybe it is a simple concept here. Really, it is more practical. We have to decide all these values based on the practice only, not theoretical things. Practice and theory both are integrated, both are sandwiching concept. Okay, this is also called integrated approach, both theory and practice. So like that, parameters and the levels have been fixed here. 1, 2, 3, 1. This is one level and okay, level 1, 2, 3 speed level, 4 levels. For this also 4 levels. 4 levels are been fixed. So this is the experimental data have been collected. Number of experiments are 16. So these are L16, L27, L9. That is depending upon this table only. So directly you can give how many number of levels and how many number of parameters. You feed it directly, you can get the experimental design. This is also called DOE. This is also called DOE, design of experiments or experimental design. So once you got it, the design, then you conduct the experiments, and note the responses or output. So what are the responses or output here? Only surface roughness is the response or output. So this surface roughness is recorded for each and every experiment. Here 16 experiments have been conducted and the response is noted here. Okay, because it is a single response, only one response here, single response optimization methodology can be applied for this. Single response optimization methodology can be. So one of the leading concept, single response methodology is S/N ratio analysis. So that was applied here, S/N ratio analysis, and then data was analyzed, and best combination has been identified. Okay, this is S/N ratio analysis. So for each and every experiment, this is the response. For this response, S/N ratio values have been calculated, and then ranks and all. This is analysis. And finally, optimum control parameters for S/N ratio. Speed is 1800 and feed is 250. This is best value for parameter. Then prediction of values by using ANN. ANN is one of the important concept for predicting the either responses or influential parameter. Reverse way also we can do. So this is a model like this has been developed. So input layer here, all inputs should be given, and hidden layers, processing layer, and then output layer. So this type of model have been developed, and finally we can predict the output. For example, for certain input parameters, what is the output? Directly you can get it like a calculator. You feed, then finally you can get the output. For example, y equal to mx plus c, y is equal to mx plus c. So you give x value and c value, directly you can get the y value. So like that, the prediction model has been developed, and from that we can obtain the values directly. So based on this final table, once you conduct the confirmation experiment, and this is ANN values inputs. So through ANN, 1800, 250 this. Okay. Predict experimental value is this. Then Taguchi, again you conduct the experiments. Not applicable means for Taguchi method, no predicted value. Directly for ANN value, you can get it. This is the predicted value, and this is the experimental value. Okay, for through ANN, this is the value, and through experiment, and this is the value. Means this is predicted value, this is the experimental value. So narrow difference, almost same, both are same. Only one drawback in ANN is we need more number of data points. Otherwise, we cannot train the ANN model. That is one of the drawback. The experimental cost is also high in the case of ANN. Okay, for that reason, so generally it is more useful in research laboratories. There they have bulk experimental data. Easily they can train it, and from that they can predict whatever they want. Training of ANN, this is one of the important concepts here. It requires more data points. You need more data points means you have to conduct more number of experiments. So it could not be possible. It could not possible. It could not be possible in majority of the cases due to the experimentation cost. Okay, so like that we can do. Right. Okay. Right. Rajesh.
Sir.
Okay, na? Then now
Yes,
I'm
sir.
concluding this with it. Huh? So all
Thank you,
these
sir. Thank
activities have been presented. Okay, due to net problem, some continuity is missed.
Sir, no problem, sir. We understand, sir. No issue, sir. Sir, now shall we go with the vote of thanks, sir?
Yeah, I'm concluding. Thank you. Okay, you may proceed.
Okay, sir. Before that, can we go for any question answers, sir? One or two questions.
Yes.
Students, I hope you have enjoyed the lecture. So any doubts regarding this lecture, you can please ask. You can unmute yourself and you can
Yes.
ask sir itself.
Yes, you ask me, I will clarify. Okay. Good.
Students, we have 55 students. Any doubts?
Hello, sir. This is Neeraj Kumar.
Good.
Sir, you have said about the just a minute, Taguchi approach, and you have also given about ANN, sir.
Yeah.
Which one do you think is more reliable?
Hello. Which one?
Which one
Your
do you think is
question-
more reliable?
Repeat again. Which one?
Which one do you think is more reliable, sir?
Actually, Taguchi method is reliable. Prediction is always maybe it is subjected to probabilistic one. Prediction means just expectation. That's all. Taguchi method is always good. It is a practical one.
Okay, sir. Thank you, sir.
Right.
Any other questions from the students? It seems that there are no questions, sir. Sir, I will go with the concluding remarks, then the vote of thanks, sir. Sir, before that, there is a small information for the students. So don't leave this meeting hall. We will be providing a feedback link. You have to fill. Then only your attendance will be considered. This is a note for students only. Sir, thank you for your excellent presentation, sir. You have given a complete 360-degree information about the optimization techniques. You have started with what is optimization in manufacturing, and the different methods for optimizations. That is the Taguchi method, gray relation analysis, fuzzy logic, and as well as genetic algorithm. And you have also showed the wonderful case studies what we have did in our lab, SV University. And also, we thank you very much, sir. Now, the vote of thanks will be from Mr. Ramana of third year. Ramana, you please go ahead.
Good evening to one and all. It has been our pleasure to host all the participants of the webinar on optimizing technique in mechanical engineering. These participants were very enthusiastic. I am thankful to all the students for attending this webinar. We have been fortunate to have the person to academia working in the area of optimizing techniques. We are sure that the students must have benefited by attending the webinar. We sincerely thank our college management for providing us necessary infrastructure for organizing the event, and we thank Dr. N. Sudhakar Reddy, sir, Principal of SVCE, for kindly accord the permission to conduct this event. We honestly thank Dr. P. Venkata Ramaya, sir, HOD Department of Mechanical Engineering at SV in University Tirupati, for accepting our invitation and delivering precious talk to all our participants. Thank you, one and all. Thank you for this given golden opportunity.
Oh, thank you, Mr. Ramana. Sir, thank you, sir. Ramay, sir. We are.
Rajesh, okay.
Sir, thank you very much, sir.
Right,
So, thank you, sir. Thank you.
Sir,
Thank you. Thank
Sir,
you,
thank you, sir.
Sri
Thank you very much for coming and accepting our invitation and delivering lecture, sir.
Good. Okay.
Thank you very much, sir.
Thank you. Okay. No mention, please. Right.
Right, sir. Thank you.
Now I'm
that's-
leaving now. Okay.
Yes,
Are
sir,
you
you can
permitting
leave,
me? Leave?
Yes, sir. Please, sir. Please.
Okay.
Students, the feedback form is posted on the link, Google Meet. You please fill the feedback link. Do not share to others. After filling the feedback link, I think you can leave. No issue.